Hi everyone, welcome back to CHM421 Analytical Chemistry. In this video, we will learn new topic 5 on gravimetric analysis. As usual, I would like to remind the description of this subject. This subject, analytical chemistry, is the course involve theory and techniques in analytical chemistry. Student will define concept, explain the principle in application, solve qualitative and quantitative problems, and perform investigation via laboratory exercise. The outcome should be assessed through paper examination, test and quizzes, laboratory skills, and laboratory report. Remember, at the end of the course, students should be able to describe the function of laboratory apparatus, standard laboratory techniques, as well as the principle involved in sampling and preparing laboratory samples. Explain the principle in application of volumetric, gravimetric, and basic chromatography analysis to solve the reliability of experimental data. Demonstrate the theory covered by performing experiment on volumetric titration, gravimetric analysis, and chromatography. Report on experimental findings in scientific manner. This is the outline for topic 5, gravimetric analysis. So you will learn about gravimetric method. In the gravimetric method is a method due to the gravity effect. So meaning that the precipitate will form. So in this topic, you will learn precipitate in precipitating agent, condition for precipitation, polite in crystalline precipitate, and also filtering, drying, and igniting precipitate. So we will uh, learn a little bit on the gravimetric method. Uh, Gravimetric methods of analysis are based on mass measurement using analytical balance. So remember, this gravimetric method, which is due to the gravity effect, is based on the mass measurement. We measured the mass using analytical balance. So analytical balance is the instrument, highly accurate and also precise data. So gravimetric method is the most accurate method of chemical analysis. During the measurement of mass of reaction stoichiometry to determine the amount of analyte in the sample. All right. So we use gravimetric method to determine the amount of analyte in the sample. In previous topic 4, we determined the amount of analyte in the sample using titration technique. We divided into 4 types of titration technique: acid-base titration, complexometric titration, precipitation titration, and also redox titration. But in here, we're gonna to determine the amount of analyte in whatever sample by concept of gravimetric method. In the gravimetric method, the precipitation will be formed. So the mass of precipitate will be measured using the analytical balance. That is the overall or the overview of gravimetric method. Okay, for the successful gravimetric procedure, so they have a few requirements to be gravimetric method to be success. First, identify the insoluble form of analyte because we want to determine the mass of analyte or the amount of analyte in the sample. So first of all, we have to identify the insoluble form of analyte. So analyte, which is in the soluble form, we convert it into analyte in insoluble form. So first step is identify insoluble form of analyte. So after that, separate the analyte from any constituent that may interfere. So the keyword is after we form the insoluble form of analyte, we have to do the separation. We separate the insoluble analyte from the constituent. Next, after we separate the form of insoluble analyte, which is normally in precipitate form, so we have to wash the precipitate that we separated to remove the impurities or co-precipitation. After we wash, of course, you need to dry. Okay. Last but not least, we convert the dried precipitate, the washed and dried precipitate to reliable weighing form, meaning that in the stable form, and then we can weigh in order to know the mass of analyte in the sample. So this is the steps for successful gravimetric procedure. It's a very straightforward. So first, identify the insoluble form of analyte. If it's soluble, and then convert it into insoluble. And then after that, you separate the analyte from constituent. After you separate it in form of precipitate, and then you have to wash and then dry. And then last, you have to weigh the wash in dry precipitate in order to know the mass of analyte in the sample. Okay, so what are the advantages of gravimetric method? Gravimetric methods normally is no calibration needed, no standardization required like that we frequently use in titration. The result is calculated directly. Why? Because we just measured the mass of the analyte using the analytical balance. So it's less messy compared to other methods because the result obtained is very accurate because it required only one accurate analytical balance. So the another advantage is we can apply for larger sample. Okay, if there are advantages, of course, gravimetric method also has some disadvantages. So the disadvantages of this gravimetric method is it required long experimental hours. Why it long? Because first, from the step for successful You just imagine you have to identify the insoluble. You have to separate the precipitate, and then you have to wash. After wash, you have to dry. So the drying step, it requires maybe 24 hours or more, maybe more than 24 hours. uh, the drying treatment, and then you have to wait. So the disadvantages is long experimental hours due to the heating or drying of the sample in the weighing form. That is the disadvantage of this technique. It's a time consuming. All right. Uh, There are three types of gravimetric method. However, in this syllabus, we will learn about only two methods: precipitation method and also volatilization method. Okay, what is precipitation method? Precipitation method, the analyte in the sample is converted into insoluble precipitate by selective agent. So the analyte in the sample that you want to analyze is converted into insoluble precipitate. Okay, so by using selective agent, so meaning that it use precipitating agent, and then as usual, followed by filtration to separate the precipitate with potential interference, and then we have to wash to remove the impurities, and then convert to the product of non-composition by using heating treatment, uh, and lastly we have to weigh using the analytical balance. Okay, so this is the example to determine amount of lead PB or plumbum in the solid soluble salt. So remember, first we have to convert the analyte into the insoluble form. So in this case, the solid soluble salt containing Pb2 plus in other chemical species will be dissolved using particular solvent. And then the solution with dissolved Pb in other chemical species, meaning that the after you add on a certain amount of solvent, the Pb ion in other chemical species will be dissolved. And after that, you have to add the precipitating agent or selective agent. So the precipitating agent used in the example is this sulfate-based agent, SO4 minus agent. So after you add on the sulfate-based agent, so the sulfate will capture the Pb ion to form the solid Pb sulfate. Okay, it form the solid PbSO4, and the solution with other chemical species are left over the sulfate. After the precipitate form, you can do the next procedure, filter, and then you can wash as well, and then you can dry, and then after that you can weigh using the analytical balance. Okay, determination the amount of calcium in water. So this is another example. Just now we determined the amount of Pb in the sample. We add on sulfate. So the Pb ion will be formed in soluble precipitate, which is Pb sulfate. So in this case, we will determine the amount of calcium in water. So In order to determine the amount of calcium in water, we can add excess amount of oxalic acid uh, to the water sample, and then we adding ammonia to convert all calcium in the sample to calcium oxalate. So the sample, the water sample containing calcium will be reacted with excess amount of oxalic acid in this condition. This is why we put it ammonia. So all the calcium will reacted with oxalate ion to form calcium oxalate. So the precipitate, this calcium oxalate is a solid precipitate, is insoluble. So the precipitate will be filtered in order to collect it, and then we collect the precipitate using the wave filtering crucible, dried, and then we can ignite. Ignite meaning that we apply a certain heat to convert the precipitate, the calcium oxalate, into the insoluble form, which is calcium oxide. So as you can see from step number 1, step number 2, the calcium ion in water will be captured by oxalate ion, and then the oxalate ion, and then the calcium oxalate will be precipitated out, and then apply the heat treatment to convert it into insoluble precipitate, which is in this case a calcium oxide. So calcium oxalate converted to calcium oxide, and then release certain gas, carbon monoxide gas or carbon dioxide gas. So the crucible in precipitate cold weight in the weight of calcium is determined by subtraction of the known weight of crucible. Okay, so this is a normal procedure when you do the heating in the laboratory. You have to weigh first the crucible before you dry the precipitate. So the calcium content can be calculated in the form of calcium oxide. Okay, so moving on to volatilization method. Just now is precipitation method. So the analyte is precipitated in a form of insoluble insoluble precipitate. So now we focus on the volatilization method. So the analyte in the sample will be volatilized at suitable temperature. Okay, as compared to the precipitation method, the analyte will be precipitated out, but in this case, the analyte will be volatilized. So the volatile products is then collected and weighed. Uh, the volatile product collected in weight, or alternatively, we can determine the weight of product indirectly by using the weight loss of the sample. So in here there is a direct measurement or indirect measurement. Direct measurement, the volatile product we collect and we weigh, or indirect, the amount of the product is determined by measured the weight loss of the sample after apply certain heat treatment. All right. Uh, okay. So this slide is to discuss the determination, the example of volatilization method, determine the NaSCO3, sodium hydroxide carbonate content of interstate tablet. So we weigh a quantity of the fine ground sample. The weight quantity of the fine ground sample is treated with diluted sulfuric acid to convert to sodium hydrogen carbonate. Okay, so the sample we treated with the sulfuric acid to convert the sodium hydrogen carbonate. Because we want to determine the sodium hydrogen carbonate, we convert it into CO2, okay, carbon dioxide. This reaction is carried out in the flask that is connected with the wave absorption tube. So because it's the volatilization technique, meaning that the expected product or expected analyte will be volatile. This is why we need absorption tube. So the absorption tube is containing adsorbent, so it can retain or it can absorb the CO2. Because remember, the sodium hydrogen carbonate will be converted into CO2. CO2 will be volatile. So the CO2 volatile or CO2 release will be absorbed in the absorption tube. Okay, when the solution heated. Okay. The difference in way of the tube before and after absorption is used to calculate the amount of sodium hydrogen carbonate. So meaning that the way of absorption tube before absorption or after absorption is equivalent to the amount of sodium hydrogen carbonate, because after absorption CO2 will be absorbed in the absorbent. So this is the chemical equation. The sodium hydrogen carbonate will be reacted with sulfuric acid, converted into CO2. So CO2 will be released, will be evaporate, or it will be volatile when the solution heated. So the volatile CO2 will be absorbed on the absorbent. So how do we measure? We measure by different way the tube before and after absorption. All right. So for successful gravimetric analysis, uh, this is the step. As I mentioned it many times, uh, we need to do a preliminary treatment, and then after that we precipitate. After you precipitate, you have to filter wash and you drying or igniting to convert it into a non-composition, and then we weighing. Last we do the calculation. So still remember I mentioned about the selective agent or the precipitating agent. So the precipitating agent should be as selective towards the analyte that we want to determine. So the precipitating agents should be specific and selective with the analyte. The ideal precipitating agent or reagent, it should react with the analyte to give the product. So the product should be can be filtered and can be washed to remove any contamination. Uh, the resulted product, it should be low soluble, so it's not dissolved, in order to avoid no significant loss of the analyte during filtration or washing. And the form product also should be unreactive with the atmosphere. And then after we do the drying in igniting and the heating treatment, it can form non-composition, so it can make us easy to do the calculation to determine the mass. So non-composition after it's dried or after it ignited. Okay, so as I mentioned just now, the precipitating agent, it should be selective or specific. So if you still remember in the precipitation titration, we use silver iron or argentometric experiment. In the argentometric titration, we use argentum or silver iron to precipitate the in iron on the halide or the thiocyanide. So it should be selective. So or can be specific. So this the example I given here is DMG, dimethyl glycozyme. So the DMG will be reacted with nickel iron, for example, to form a solid of nickel, DMG. So this is the criteria in order to be participating agent. It should be selective and specific. Okay, so in this table, it gives some organic precipitating agent. You can have a look, but no need to remember. So this is the DMG, dimethylgloxime. This is the chemical structure of the DMG. So no need to remember this one. I just let you know we have a few example, many example of organic precipitating agent. Okay, so now we talking about the properties of precipitate. So the properties of precipitate. The precipitate is the insoluble form of analyte that precipitate after we filter, and then we wash, dry, ignite, and then we weigh or we measure. So the properties of the precipitate. A granular precipitate is very normally a granular form of precipitate we use or desirable in gravimetric analysis. Granular meaning powder like, is a powder like. Okay. So the granular precipitate normally small surface area, high purity, and also is easier to filter. So the precipitate in the granular form is very desirable in the gravimetric analysis. The precipitate made up of large particles are also desirable in gravimetric analysis because large particles are easy to filter in wash to remove the impurities and it become more purer. So the precipitate form, either in granular or in the largest particle, it should be low solubility in the solution. So the precipitate form, it should be low soluble. Okay, it cannot be dissolved in the solution that we use. Okay, large particles in granular form can be achieved. So how do we achieve a larger granular particles? First, lowering the temperature slowly. Okay, we lower the temperature, uh, and we can add the organic solvent that can mix with water. Okay, so nucleation is the process of form nucleus before it form particle nucleation. So nucleation is the initial formation process. Is the first formation process in which a minimum number of atom or ion or molecule join together to give a stable solid. This is nucleation. Okay, it can be nucleation. So the number of nucleation site, it can be many. Fine grain structure. Rapid cooling will cause many rapid cooling. So meaning that the cooling process we done it rapidly. It can cause many nucleation site or number of nucleation site can be a few if we have a larger grain structure. Okay. So larger grain structure is only a few number of nucleation site. So in order to form a large grain structure, so the cooling done slowly, so it can form a few crystal. Okay. So if we have a fine grain structure, so now the number of nucleation site is a very many. So it can be done by cooling rapidly, or if we have large grain structure, so the nucleation sites only a few. It can be done by cooling slowly. So when we cool slowly, a few crystal will be formed. Okay, this showing the schematic diagram of nucleation in also particle grow. Particle grow is the subsequent grow after nucleation. So meaning that after nucleation step, a particle will keep growing. So spontaneous nucleation will occur on its own. This is a spontaneous nucleation. Induced nucleation, it require foreign agent, or we call it seed particle, to get things started. So uh, induce, we meaning that we introduce impurities, or we introduce something to initiate the nucleation. So after nucleation, the particle can grow. Once nucleation site is formed, other ions are attracted to the site. So remember, when the nucleation sites can have many, or when we can have only a few of nucleation sites. So this will result the formation of large and filterable particles. If it done properly, it reduces the contamination since they don't fit in the crystal growth. Okay, so from the nucleation, either many nucleation site or a few nucleation site, and then it can form crystal. So the crystal will be the nucleation will be grown to form a particle, or to form the crystal. Okay, I think that's all for this video. We will continue on the next video on the particle size and other subtopic. Okay, thank you very much. See you again on the next video.